Hello and welcome to the second part of session on center of gravity. Hi, I am Professor Jairam V, Department of Mechanical Engineering, Luth Mada College of Science and Technology, and the whole work is done as a part of FTP 201X conducted by IIT Bombay. Today we will discuss about center of gravity and in specific we will discuss on center of gravity of cutout section. The concepts of center of gravity has already been discussed in the previous videos. So let us look into the problem. Here it is actually a composite section. Composites in the sense we have actually two different geometry. As you can see, the blue region is actually which is left. Actually, it is we need to find the center of gravity of the shaded section. So it consists of really two sections. One is a rectangular section, that is 6000 by 600 6000 mm square section, and followed by there is actually a right angle triangle which is embedded in it. So all these dimensions are in mm. So we will continue with the same practice. First we need to redraw the figure with necessary dimensions. So that's done. We have all the dimension and it has been completely redrawn. Next, we have to draw the axis about which the center of gravity of the composite section is to be designated. And you'll have to keep in mind, while drawing the axis, we need to locate the origin also. It is usually at the bottom left. And the last but not the least is to divide the composite section into non-geometry. Here we have two different geometries, so we'll name it as 1 and 2. So the first section is a square section, and the second is actually a right angle triangle. Next, we will individually locate the center of gravity of these sections. As you can see, I have located it as G1 and G2. And let us take the first section, that is we have a rectangle, we have a square with 6000 by 6000 side, and you can locate the center of gravity of the first section as G1. It is 3000 from either of the axis. It is clearly mentioned. And when you talk about the right angle triangle, as you can see, it is located, the center of gravity of the right angle triangle is located as G2. It is designated as G2. Here it is. Here the center of gravity is located, and it is around 3000. Okay, so I have intentionally, actually the G2 falls within G1 because you can see that both X and Y happens to have the same dimension. So in fact I should show both G1 and G2 with the in the same point. But for a better understanding, so these are basically rough works, isn't it? So for a better understanding, we'll move with this, as you can see, and you'll also have to remember that the width and the height of the triangle is B and H, and the center of gravity, that is G2, is located from this region, and it is usually B by 3 and H by 3. So the width is around 3000. So 3000 by 3 gives you 1000. From here it is 1000, and but we need to locate X from Y axis, isn't it? So you have to reduce that 3000 by 3 from 4000. Then only you will be able to get 3000. So these are the areas which should be kept in mind. These are the tricky parts. And here also the y axis, the y distance is usually h by 3. So h by 3, in the sense, here it is 3000 by 3, and this should be added to 2000. Then only you'll be able to get 3000 here. So now all the dimensions are drawn, and we'll move on to the table. So as discussed in the previous problem, we have a section, we have area, coordinates are often located as x1, xi, and yi. So the product of these two columns, that is AI and XI and AI and YI, are the next two columns, and definitely the dimensions are also written there. Now you can see the first section, which is a rectangular or a square section basically. So the area is designated here. Then all of the necessary dimensions are also located, as you can see. We'll move to the next section. In here also it is basically a rectangle. It's a triangle. So the area is floated with x-axis and y-axis, and the product is also shown. So once we have these, we'll have to find the summation of these, that is the area. Here you'll have to keep in mind this is a cutout section. Actually, a triangular section is cut from a rectangular section, that is 2 is cut from 1. So instead of adding this area, you'll have to subtract, that is 36 into 10 raised to 6 is reduced from 18 into 10 raised to 6. So you get around 18 into 10 raised to 6. Okay, the 36 into 10 raised to 6 minus 18 into 10 raised to 6. Next, what we do is actually find sigma AIXI. Here also, since it is a cutout section, what we are going to do is we're going to reduce 108 into 10 raised to 9 minus 54 into 10 raised to 9. So we get around 554 into 10 raised to 9. So the same value is also found here, that is AI, sigma AI, YI. So once you have these values, that is sigma AI XI, sigma AI YI, and sigma A, you can simply finish off the problem by using these simple formulas. That is x bar is equal to sigma AI XI by sigma AI. You get around 3000 mm, and the y bar is also 3000 mm. Then finally you'll have to redraw the figure, locate x bar and y bar, and put the answers in a box. Thank you for listening.